Hey everybody, I have promised my students to do a quick video capture rundown of Cisco Packet Tracer, where I'm going to set up two subnets connected with a router, or maybe three subnets with one router, and one of the subnets has a DHCP server in it, and the goal here is really to get the DHCP relay working. So you'll see. I'll just throw this up here real quick. Let's use this router here. With three switches, one for each subnet. We're assuming this is like three departments in a company or something. We connect them gigabit to gigabit port. When you do this, keep an eye on which ports you connect which subnet to here on the router. So currently I'm using 00 here, 01 here, and 02 is going to be this one here. Maybe let me just label them. So just so we don't lose track of who's who here. And I'm gonna make an address scheme here that I used in class already, just to stay consistent with that. Everybody's on the same page here. So first of all, I'm just going to configure my router here. I'm going to configure those three Ethernet ports, and I'm just going to pick the gateways right now, right away. I'm going to decide the first usable address of each subnet will be the default gateway in each of them. So 00, my network ID is 102030 0, so I'm going to use the 1031 as the gateway for that subnet. Subnet mask accordingly, and that's that one. The one on the right here is going to be 40, 192, and the one towards the south. Sorry, I just noticed I didn't write that in earlier. Okay. Okay, so I'm going to turn my three network ports on. And the router is good for now. So now we're bringing in a few end devices. We're going to connect them to the switch. Alright, I can forward the time a little bit here if it takes too long, if I'm getting impatient with those ports to come online. Here we are. So subnet 3, subnet 2, subnet 1 connected to these ports. So I bring in a server now. In the end devices, here's a server. Let's just put it here. If I connect it, the DHCP server needs to be configured manually. It needs to get its static IP address. So here, just click on the server, on the desktop. That's the easiest way to do it. IP configuration, and I give it a static IP address. I make this a member of subnet 1, so that is my network here. 102030 cannot use that because that's the network ID. .1 is already in use, that's my default gateway. So I can make this 2. Subnet mask according subnet mask needs to match with my planning here, and the default gateway will be this address. The Ethernet port on the router connected to that subnet. There we go. So this is good. At this moment, this subnet is functional. I can actually test if I can ping from the server to the router here. Let's try that. Close the desktop. Here's the command prompt. There's the ping. Oops, my caps lock's on. So the 10.20.30.1, which is here. And I get a reply. I should also be able to ping the 10.20.40.1, which is this one, and the 10.20.50.1, which is this one. Let's try that. So the router works, everything is configured, and in itself makes sense. Okay, so to make this server a DHCP server specifically, I close the command prompt and I go into the services. So this window is this server here. Services, and I go to the DHCP section. I turn the service on, and it has already populated this area here with the configuration it pulled from its own NIC, from its own network card that I just put in manually. So I'm not sure why Cisco Packet Tracer does this, but it suggests the start IP address 10.20.30.0. In my mind, that's not good because that's the network ID. I actually don't know if it would actually issue this, but I don't want it to start here. I don't want it to start at 1 either because that's my default gateway. I like to plan a little ahead for the future and leave a small number of low addresses untouched by the DHCP, so it will not give those out. So I could start here at, let's just say 10. So the first IP it will hand out to any incoming requests will be 10.20.30.10. Subnet mask is correct. This needs to be transmitted to the others upon request. And the default gateway here will be 10.20.30.1. Now if I save this, it writes it into this server pool here. This is where the magic's going to happen in a minute. At the moment, when I close this subnet is working. I can go to this host now and go to IP configuration and switch it to DHCP, and it should get the configuration from the server. So the DHCP works, and if I bring in new devices here, it'll be all the same. Good. Here's the tricky part now. We know that subnets can't have overlapping IP ranges, scopes. We know each subnet needs to have its own pool of addresses, and I made those like this so they're very easy to distinguish. Okay, we also know that a DHCP request is a broadcast. So when a new host comes in, just say a new PC comes in here, I connect it. The moment I switch this to DHCP, it doesn't know its address yet, right? It doesn't know anything. It doesn't know the subnet mask or whatever. So it sends a DHCP request to 255, 255, 255, 255. And it'll arrive here, and this will respond and give it its information. But that request will also go here. So what happens if these send a request? They send also 255, 255, 255, 255 DHCP request. it'll go to everyone connected. A router will not let this broadcast pass across. A router will not transfer a broadcast across. So that means these effectively can never reach the server. Therefore, they can't get DHCP configuration. So one way would be to put a DHCP server in here and another DHCP server in here and make them individual for each subnet. That seems inefficient though, because here in a model, who cares? In real life, you would have to have some hardware that has DHCP abilities and configure that, and you would have to have that in each subnet. Imagine you have a company with 80 departments, or a school district with probably easily 100 or 200 subnets. That's not efficient. A single server can do that. You saw earlier, when I went to the services here, that this is called a server pool. I can make multiple pools, one for each subnet. So this one's already good and it fits here. So let me do the same thing for subnet 2 and subnet 3. I'm going to make another pool that I'm going to just call server pool 1. Just add the 1 to the name here. And I'm going to make the data, the configuration information a match for the subnet 2. So this is going to be 10.20.40.1. It's going to be the gateway here. They're connected here. The start address will be 10.20.40, let's say 10 again. And the subnet mask here is 192. Okay, I'm going to save that, or I'm going to click the add button here. Now I have two pools on different subnets. I'm going to do another one for the last subnet here. Call that 10.20.50. 10.20.50. And maybe for giggles, we start at 5 here. That subnet is a little smaller. And we add this as well. The DNS server I completely ignore at this moment. We don't have anything DNS, anything requiring DNS in here. So I have 3 pools now. So this means the server can handle different subnets with their different address scopes, different requirements, different subnet masks and gateways. The trick is now, how do we get a request coming from here or here to pass across the router and find the server? Because at the moment we know that this will not let a broadcast pass through. We can actually watch that in simulation mode. If I let's go here, and I'm gonna turn on simulation mode here, and I'm switching this now to DHCP. We see the data packet be generated here. Now click play. Let's watch the simulation. Here comes the broadcast, and it should, this will be our target, and the router as well as the other hosts just eliminate that packet. Nothing's happening. So back to real time. We need to do something to this router to let it pass this request across and turn the broadcast coming from here into a unicast directly to this one specific target. So for that I need to know my DHCP server's IP address. Here it is, 10.20.30.2. And now we're going into the command line interface in the router. Click on it. Packet Tracer really gives you the same layout and everything that you would get on the actual device, as long as it's Cisco. And if I click on the command line interface, it gives me the same experience. In order to configure this device, I need to press return to get started. Return is just, it's really old-timey for enter. So we see the router showing up with the prompt here. At the moment you can't configure anything. You got to get into executive mode first. To do that you type in enable and press enter. Now you see that little hashtag #, and this is now ready to take commands from you. And what we need to do is we need to configure the terminal here. Short for that is conft. And when you enter, you see that it now gives you a prompt that indicates it's ready for configuration. Now all we need to do is configure this port here, Gigabit Ethernet 01 and Gigabit Ethernet 02, to relay a DHCP request. We turn this into a DHCP relay agent by allowing incoming DHCP requests on here and here to pass through and be directed to here. That's the idea. To do this, I need to specify which interface I'm configuring. You type interface, Gigabit Ethernet, and now this one is 0/1. That's the name of the interface. Now you see the prompt change to config-if. That tells me I'm configuring an interface, specifically this one now. And here comes the magic sauce. You gotta use this command, IP space helper-address, and specify the target's IP address. I just looked it up, it was here, 10.20.30.2. And press enter. If you don't get a response, that's usually a good sign. Now I gotta do the same thing to the other interface. Now when you're in a command line interface, you can use your cursor up key, the arrow up on your keyboard, and go through the history of your previous commands and just find one that's like you need it. So just go up here, and it's going to change this to 0/2. That switches me to the other interface, and I'm going to use that same command again, IP helper address 10.20.32. So I applied this command to this Ethernet interface and to this Ethernet interface. This one doesn't need it because this is the side that has the server anyway. So I'm going to enter this. I can exit here, and close this, and I should be good now. Now I should be able to go into a host on this side and switch this to DHCP, and this is successful. Let's watch this one more time in simulation mode. I'm going to go here, switch this one to DHCP. Here we see the packet generated here, and now I'm going to click play and we watch the simulation play out. Broadcast, transmitted by the switch to everywhere, because that's what broadcasts do. The router doesn't discard the packet anymore because it has a relay to this target, so sends it specifically there. So it's not a broadcast anymore, it's already a unicast. This one responds, sends the information back, switch back to real time. Now it's successful. So, what have we done? We have set up a router, as we always did, for 3 subnets. We have included a DHCP server, but this time we didn't have the DHCP server only serve one server pool, but instead 3 with different IP addresses, start addresses, subnet masks, and default gateways. And we allowed the router to pass through these broadcasts to a specific unicast target. So the incoming broadcast request that is searching for, hey, is there a DHCP server around here somewhere? Please, somebody tell me what my configuration is. This specific request is handed over and directed to the actual DHCP server, so every new incoming device gets an IP now. So if we, let's just say we make put a wireless access point on this side here for the phones in the building. They all connect to the wireless access point. And if I check, the IP is not set yet. It takes a moment, I guess. Fast forward here for a few seconds. Okay, there we are. 102040. They're part of this subnet here, 102040. All smartphones are on that access point. That is part of that subnet. The individual phone sends a DHCP request the moment it found the access point. The access point sent the request as a broadcast. So that means everyone on that subnet got it. These two can't do anything with it. The router knows, hey, I have a relay, I have a target for this specific address, and moves it over here. The DHCP server receives the request, sends the data for the pool number 2 that aligns with this subnet, because it knows that's where it came from the source address. And these hosts get their respective configuration. I hope this helps a little bit. If you struggle with this kind of setup, this is part, like I said, this is part of my school lab right now, but maybe it helps someone else too, I don't know, but specifically my students. Maybe use this for reference if you're stuck on certain points. This is exactly what we did. Everybody have a good day, and bye-bye.